Welcome to lecture number 13 of Software Requirements Engineering, CSE305. And in today's lecture, we are going to continue our discussion on the elaboration process. But before we start our today's have a look at today's contents, let's quickly recap what we covered in our previous lecture. So our previous lecture was again on elaboration process, and we have been discussing this topic of elaboration process for past 2 lectures now. And specifically we looked at one of the approaches of doing this elaboration or doing analysis, and that is object-oriented analysis or object-oriented approach of analysis. And within object-oriented, we already discussed that there are 3 main modeling techniques which can be applied. One is scenario-based modeling, the other is class-based modeling, and the third one is behavioral modeling. So we started our discussion with the scenario-based modeling, and within scenario-based modeling we looked at use cases, we also looked at activity diagrams, and as I said, we were short of time and we were not able to look at a swimline diagram. So just to give you guys a quick recap, because I'm sure that you are already familiar with these diagrams, I will just quickly show you that how a swimline diagram looks like. But one thing that we need to understand as requirement engineers or as requirement analysts, that the purpose of introducing these diagrams once again to you is not to let you know that how you can draw a use case or what are the notations in a use case, but the purpose as a requirement analyst is that how you can use these different kind of diagrams to understand the requirements and to gain more understanding about the functionality of the product. And it is important that you appreciate that by making these diagrams, we can actually gain more understanding into the functionality of the product. So let's look back at the example, one of the examples that we were doing yesterday. And so let's imagine that as a requirement analyst, I've gathered this scenario. So let's try to figure out the scenario, and let's see how use cases helped us in understanding more about the functionality of that particular scenario, or what events would be occurring in that particular scenario when we actually make the product. So let's say that our scenario was that we are making an ATM system. So we know that the system that we are going to design is the ATM system, and we as requirement engineers, we went to elicit requirements and we got a scenario, and the scenario was of cash withdrawal. And we talked to people and we gathered requirements, and we came to know that what would happen when somebody wants to withdraw cash from an ATM machine or from an ATM system. So what would happen, that a user would go to ATM machine, insert ATM card, enter its PIN number, and select transaction type, which is basically withdraw cash, and then what would happen after withdrawing cash, he will receive cash. So let's say this was as a requirement analyst, when we went and we started eliciting requirements from our end users or from the stakeholders. We came to know that this is one of the scenarios that we need to model, or we need to develop in the ATM system that we are going to make. So let's look at the example that we discussed yesterday and try to understand that why we are discussing these modeling techniques as the requirement engineers, and why they are helpful in understanding the requirements, and how we are going to gain more knowledge about the system by using these different kind of diagrams. Because always remember that you should use these diagrams if they are adding to the information that you already have. If a diagram is useless in a particular context, then we don't need to make it just for the sake of it. So this is very important to understand from software engineering point of view, because sometimes people take it as this is a very boring activity, and this is they take it as a burden. But if you really understand the usefulness of these diagrams, then you can actually appreciate that they are really helpful, and then you can, if you do it properly, then I'm sure it's going to resolve lots of conflicts, lots of problems, lots of inconsistencies and ambiguities in the requirements, and it will clarify lots of things which you might miss otherwise. So for example, we had this scenario, and we thought, okay, let's do scenario-based modeling and let's try to make a use case diagram. So when we looked at this particular scenario, one of the actor that we can just figure out by just looking at it is this user. So we come to know that there is this one person who is the actor, and we define actor as somebody who is interacting with the system, who is outside the boundary of the system that we are going to. So our subject in this case is ATM system. Okay, and we as developers, or we as a company who is making this ATM system for a client, we have to design this ATM system. So that is the subject, and that is the boundary of the system. So anything that is outside the boundary is an actor. So that can be a person, it can be a machine, or it can be another system. So we know that there is a user, and we looked at that there is always a use case boundary, and we recap that. So this user, he is going to do a transaction, and that transaction is basically withdraw cash. Okay, so we got to know that. But one thing, when we look at this diagram, one thing which really strikes you, that it is impossible for a user to just withdraw cash from a machine without actually confirming that withdrawing, that whether the user has certain amount of balance in his account or not, whether the information that he is supplying is correct or not, whether he is on the banking network or not. So we come to know, okay, that there is some other system. We need to verify the details of this user from another system, and that other system we may call it the banking system. So this is not a person, but it's another system which is outside the boundary of this ATM system, which is our subject. So we get to know, okay, that we looked at this scenario as when we were eliciting, and nobody mentioned this banking system. But when we started making this diagram, we understood, okay, if somebody is going to withdraw cash, then we need to authenticate it from someone else. So let's say this is the use case diagram that we ended up with. So it told us few things, that a user needs to withdraw cash, and when he is withdrawing cash, he needs to, for example, enter the card, enter the PIN number, and he needs to do so many other things. So we might bundle all these things. So for example, we may have a use case which we call every transaction must have, and we merge these four things in it. For example, number one is ATM card insertion, number two is entering PIN number, and then number three is maybe selecting language. So we enter all these things into this one, and we say, okay, we are going to include this functionality to this use case. So this use case which says every transaction should include, this basically is included by this particular. So we know, okay, that this functionality is common to multiple transaction types, and because it's common, so we have bundled it in one use case and we are including it in this transaction. Similarly, a user can perform another transaction. For example, he wants to check his balance, and in that case this is also included. So that's why we have bundled all this functionality into one. So when we start drawing it start telling us few very interesting things. But now, but that is not enough for us as an analyst. So we say, okay, this is the normal flow of events that I can model and I can draw using a use case diagram. But let's start writing the use case text, and I actually want to analyze all the events that are happening in this normal flow. So for example, I start writing use case text. And if you guys remember that when we were writing use case text, there were lots of different things which are part of a use case template. So for example, we said that in a use case template, we will have use case ID, we will have a use case number, and a use case name, we will have its description, we will have some preconditions, and we will also have some post conditions. We will have normal events, and then comes the very interesting bit which I like the most about when we're writing these use case text, and those two things were number one was alternative actions, and the other one was exceptions. So these two are really important, the alternative actions and exceptions. Okay, so if you look at all these normal flow of events, for example, entering the ATM card, entering the PIN number, selecting a language, selecting a particular transaction type, and then selecting withdraw cash, then entering the amount, and then pressing OK. So there are 5 or 8 or 9 different things which are happening in this particular scenario, and these are normal things. If everything goes fine, then this is how this scenario would look like. But whenever we have these scenarios, then there are alternatives possible, which we didn't actually talk about when we elicited requirement, but when we looked at it, we saw, okay, there are lots of things which can happen, which can go any other way. For example, when a user entered his PIN number, and then the machine might figure out that this user is not on this banking network. So then somebody might say, okay, then we realize, okay, we need an alternative course of action here. So we need to ask this user whether he or she wants to be included in that, or whether he wants to be charged for it or not. If the user says okay, then he will move to the next step. If he says no, then his transaction would end and the ATM card would be ejected. So that is an alternative action. Whereas an exception can also occur when a user enters his PIN number, that the PIN number is incorrect. Okay, and then we say, okay, there is an error. So there is a difference. When we identify these normal flows, there are 2 possibilities. We can either identify alternative actions corresponding to each normal flow event, and we can also find some exceptions. So this is where we really start working as an analyst, and we start analyzing, each functionality which we identified as when we're eliciting requirements, or as a result of the elicitation process. We are looking in depth about that. If this happens, then what are the other possibilities? What alternate actions can take place, or what errors can occur? Because when we are making a system, we need to develop a system which is totally foolproof and which takes care of all these things. And if we look at that exception more carefully, for example, a user enters the PIN number which is incorrect. Now we identify that this is an exception, and our system should notify the user that you have entered an incorrect PIN number, please re-enter. Okay. Now that is a functionality that we didn't think about when we were eliciting requirements. And then another very interesting functionality which you might have seen, hopefully you wouldn't have experienced it, but you might know about it, that if you enter your PIN number incorrectly a certain number of times in an ATM system, then your card is basically the system doesn't return your card. Okay, and it is held with the branch where you were trying to make that transaction, and then you have to go in there personally, and you have to show your IDs and stuff, and then you get your ATM card back, and that is very painful. So basically, so we identify. Okay, so another thing we figure out then that I will notify the user if the PIN number is incorrect, but I also need to mention that how many times, or as a system developer or as an analyst, I also need to mention that how many retries are allowed, because it is not possible that you let somebody keep on retrying and punching different numbers, and if somebody's ATM card is stolen, then you don't want the thief to guess the PIN number. So that's why you have to set a certain limit on the number of retries on the PIN numbers. So and that is another thing that comes out of it. And similarly, at times when you use those ATM systems, one exception can be that the banking network is down, and this happens to me a lot. You go to an ATM machine and you are withdrawing your cash, and you certainly figure out, okay, the banking system is down, and the machine says your transaction timed out, it is impossible to complete your transaction at the moment, and which is very annoying. But again, the ATM system, who developed the ATM system, they have set a time in the system that you will wait for this transaction to go through for a certain number of seconds or a minute or so, and then you will eject the card, or you will say, okay, we cannot do this transaction, do you want to try again, or you want to cancel the transaction? So again, why this limit is important, and we actually didn't think about it, and we didn't talk about it when we were eliciting requirements, but when we were actually analyzing our normal flow of events and we identified certain exceptions, we came to know about it, and we said, okay, we need to figure out and we need to set a time for it as well, that how much time should I wait for a transaction to go through. So that is another thing that comes out of this, making this use case text and making these use case diagrams, that we identify all these things. And similarly, another thing which we talked about yesterday as well, that you can have some supporting requirements within a use case text. For example, as I said, that you have this particular example of exception of waiting for a transaction to go through, that you set a limit that you will wait for a transaction to go through for 60 seconds, and if it doesn't go through, then you will say, okay, your transaction is timed out, and you try again. So you can mention these kind of things when you are writing these use cases, and initially, and you can see the amount of detail that we have actually came across. Initially, we had just this one small scenario that a user goes to an ATM system, he enters his card, enters his PIN number, and he would select to withdraw cash, and he should receive cash and his card back. Now that is what we gathered when we were eliciting requirements. But when we started this scenario-based modeling, and we made a use case diagram, and then we started writing use case text, then we started identifying, okay, this is the order of these events, and these are the alternative things that we have identified, and these are the exceptions that can occur, and what are we going to do when these exceptions occur, how our system is going to respond, and how our system is going to inform the user that this is happening with the system. So this is how, as a requirement engineer, you should approach all these modeling, or you should approach these particular diagrams. For example, the use case diagrams, activity diagrams, Swimline diagrams, and the diagrams that we are going to discuss in today's lecture and in our coming lecture. So we ended last lecture by looking at one of the examples, and I told you guys that this example is taken from the software engineering book, which is Practitioner's Approach to Software Engineering by Roger Pressman, and this is a very commonly used software engineering book, so I thought this example is also interesting, and you can find this example in the book, which is explained very well there as well. So the use case was of a product which is Safe Home, where you have lots of surveillance cameras in your house, and you have a security panel where you basically set in your alarm, and you can change your settings as well. So as a homeowner, what you can do, you can access different cameras, you can configure your system, you can set alarm, and that you are the main actor, you are the primary actor, then the secondary actor are the cameras which are installed. So that was the use case diagram, and we said that use case diagrams does not actually give lots of details of the events or lots of details of the alternative actions. And as we always say, a picture is worth 1,000 words. So use case text is an alternative of maybe this activity diagram, but making or showing all these alternative actions or all these exceptions that may occur when you are performing a certain interaction, when an actor is performing a certain interaction, if you draw them in an activity diagram, that it shows that in what order these activities would occur, and what would be the decision points, and what things would be occurring in parallel, and whether you would wait for a certain transaction or not. So there are lots of advantages of using activity diagrams. Again, I'm sure these topics have been covered in the software engineering course. So again, purpose for you as a requirement analyst, as a person who is going to specify requirements later on, is to understand the flow of events and how different events would interact with each other. What would be the order of these events? So for example, when somebody wants to access this camera, then the first thing the user would need to do is he or she would need to enter his ID and password. Now, whenever you are supplying this information, then there is always there is a chance that an exception may occur, and the exception is shown by this small decision box. It is shown by this decision box, and it is saying that there are two possible things. This is the normal scenario, that you have entered a valid password and ID, and then you come to here and you select the next major function that you want to do with this particular Safe Home product. And the exception is that you entered an invalid ID and password. So you can, if you enter an invalid ID and password, the system is going to prompt you for re-entry, okay? And again, there is an option in the system that you can enter a user ID and password incorrect only a certain number of times. If you exceed that, then you will exit this whole scenario, and whatever you were trying to do, your interaction would end. But if your input tries remain, you will go up again, and you will try to enter the password and ID again, and then again you will come down. If your password is correct, you will go to the normal flow of events. So you come here, and then you select this surveillance, and following that you select, okay, which view you want to look at, whether you want to look at the thumbnail view or you want to look at a specific camera. Again, there is a decision here, and these are not exceptions, but that is an alternative action. So let's say by default you selected that the thumbnail view would be visible to the user. Okay. Now again, this is something when you would have been eliciting requirements for this particular scenario, then the user might have told you that when you select surveillance, then user should be you should get the camera view. And maybe at that stage you didn't actually figure out that whether you want this option of looking at all the cameras at once, or you just want to look at one camera. So as a requirement analyst, then you started making a use case diagram, and you started making a writing use case text, and made this activity diagram. You were able to identify that there are alternative actions going on here, and there is possibility that you either can see thumbnail view of all the cameras, or you can look at a particular camera. So again, this activity diagram, it helps us in identifying those alternative actions, and it also tells us order of these events, in which order these events would occur, and how we are going to prompt certain things or inform our user. And remember, this scenario-based modeling is from user point of view. Okay, so whatever we are trying to do, we are trying to keep the user in our mind, and we are imagining that how our system is going to respond to certain interactions that user is going to perform with the system. So again, having said that this is from user's point of view, so you also want to identify as a requirement analyst that which activities a certain user is responsible for. Because we have identified there are different actors who are involved here. You have this homeowner, you have these cameras, and you want to know that there are certain actions which are being performed by the homeowner, there are certain actions which are performed by the camera, and then there are certain actions which are performed by another system. But you want to identify that which events would be performed by which actor. And then the Swimline diagram is an alternate representation of an activity diagram. If you look at these two diagrams, this activity diagram and this Swimline diagram, they are actually the same diagram, but the only difference is, if we look at these lanes, then these lanes identify all the different actors who are performing these different, or who are responsible for these different events. And what we are saying is that homeowner is the primary actor, or is the initiator of this particular sequence, and he is going to enter ID and password, and then this whole scenario would kick in, and he is responsible for all these actions. Whereas what we are saying is that we have an external interface which is responsible for displaying certain information to the user, and that is something which is outside our system boundary, and we're saying, okay, that is another actor, and this is actually prompting the user to re-enter, and then again control is coming back to the user. And then when the user selects a particular feed, for example, he wants to see feed from all the cameras, or he wants to look at one particular camera, then the camera user is doing something, and he is actually giving that feed to the system. So again, because we emphasize that this scenario-based modeling is from user's point of view, so Swimline diagrams is just a view which actually tells us that which user or which actor is responsible. So actor is important, that which actor is responsible for which activities or which events in a particular scenario. So again, just remember that activity diagram and Swimline diagram, they're exactly the same. If we get rid of these lanes, and if we merge them together, then this will become the same diagram which we saw on the previous slide. But this is just another view which actually helps us in grouping that if in a particular scenario, these are the things that this person is going to do. So we want to identify that what will be the inputs from the user to our system, and how our system is going to respond, and how our system is going to interact with other secondary actors in order to display something useful to the user. So that is it from our discussion on scenario-based modeling. Again, remember that the purpose of the previous lecture and our discussion in this lecture on these use case text, use case diagrams, activity diagrams, Swimline diagrams is not that you understand the semantics of these diagrams and you look at, so we just quickly recapped some of the elements of these diagrams, but it is important for you to understand as a requirement engineer and appreciate that how these different tools, these diagrams, they're helpful for you in understanding and extracting more information about different functionalities that a system should have or should provide from a user's point of view. Okay, so in today's lecture, as you already have seen, we have talked about Swimline diagram, and we try to compare it with the activity diagram. The main topic that we are going to cover in today's lecture is class-based modeling or class modeling. And again, if you remember that this class modeling is again a type of the object-oriented approach that we are covering. So if you remember that we said that there are two main approaches for elaboration or for analysis or analyzing the requirements that we have elicited. And of these two approaches, one was object-oriented and the other was structured. And within the object-oriented, we have covered this approach, which was scenario-based modeling, and the next approach is class-based modeling, which we are starting today, and then there is another one which is behavioral modeling. And if time permits, we will start talking about it today, but otherwise, mainly we are discussing this class-based modeling. So again, remember the thing that I've mentioned, that as a requirement engineer, your goal is not to understand that how a class diagram is drawn, because again, the expectation is that you have already done in your earlier courses on software engineering. So how do we identify domain classes? So the goal is, because remember we said that when we do analysis, then we extract more detail about the information domain and the functions and the behavior of the system. So these three words are very important. That we said in our first lecture when we started this elaboration or analysis process, that there are three things which this analysis process or this elaboration process helps us in as a requirement analyst. It tells us more about the information domain, it tells us more about the functions of the system, and also the behavior of the system. So as a requirement analyst, we are interested in that how this kind of modeling is going to help us in extracting this information. So we are going to look at that how from an elicited scenario, or how from an elicited user requirement that we have done in the elicitation process, how can we identify these domain classes? How can we know more about the information domain? And how can we know about what are the different attributes of those classes? And then what are the different operations that can be performed on the different attributes of these classes or different objects of these classes. So this is the main goal that we have today. Again, we are not looking at what is a class diagram, how we show it. We may briefly look at it, but again, there are lots of associations in a class diagram, and again, we will not go into those technicalities, because there is an assumption that you have already done that. So mainly we are going to talk about class-based modeling, and as I already said, that the first and most important thing is to identify those analysis classes or the domain classes. And like we discussed, that when we elicit requirements, we have some raw scenarios or raw stories that we have gathered from the client or from the stakeholder, and they are not structured. We have not grouped them. So what we do is that when we are trying to identify these domain classes in analysis, we are again trying to gain more information about the domain, we are trying to gain an understanding about the information domain. So how do we do it? One thing that is suggested in literature is that you do a grammatical parse. Okay, and what you do in that grammatical parse is that whatever scenarios you have, whatever use cases you have modeled, the use case text that you have written, you go through it and you try to identify what are the nouns, whatever nouns you figure out. You try to look at what verbs you have identified, and by doing so, we select a pool of nouns, we have a pool of verbs, and then we try to figure out that, and when we are identifying these domain classes, we try to figure out that out of all these nouns that we have identified, what would be the domain classes in my solution. Okay, and this is what we are going to discuss in our lecture today. So let's look at these in a stepwise fashion. That we perform a grammatical parse of the problem statement or the use cases. Classes are determined by underlining each noun or noun clause. A class required to implement a solution is part of the solution space. A class necessary only to describe a solution part is part of the problem space. A class should not have an imperative procedural name, that is a verb. List the potential class names in a table, and then we classify each class according to some taxonomy and class selection characteristics, which we are going to discuss in the next few slides. And this is very important, that a potential class should satisfy nearly all of the selection characteristics to be considered a legitimate problem domain class, and we'll see what criteria we establish for finally selecting a class as a domain class. So what we do is we make a table which is a similar table which is shown here. So what we do is that we try to we identify all those nouns and noun clauses, and we list all them here, and we say, okay, let's say we have 15 noun and noun clauses in the text that we have found. And then we have a general classification. We try to identify that which one of these class belongs to which category, whether it's a role, whether it's an entity, whether it's a what it is. We try to classify them, and there are 5-6 classification criteria. And then we have certain selection criterions as well. And all the classes that we identify, they need to satisfy all those criterions to be considered as a domain class, with the exception of maybe the essential requirements that we are going to talk about it in a bit. So let's look at how this grammatical parse is performed, and again we are going to look at the example of the safe form, for which we made that use case diagram, and we also looked at the activity diagram and the Swimline diagram. So let's say these are the different scenarios that we have gathered when we were eliciting requirements. So let's look at each one of them and try to figure out that what are nouns and what noun clauses we can figure out. So for example, let's read the first scenario or the story. So the safe home security function enables the homeowner to configure the security system when it is installed, monitor all sensors connected to the security system, and interacts with the homeowner through the internet, a PC, or a control panel. And so this is how the end user is going to explain it to you. So end user is saying that there is this security function. It enables the homeowner to configure the system. When it is installed, monitors all the sensors connected to the security system, and interacts with the homeowner through the internet PC or the control panel that is installed in the home at the entrance, or maybe. Then the next scenario is during installation, the safe home PC is used to program and configure the system. Each sensor is assigned a number, a type, a master password is programmed for arming and disarming the system, and telephone numbers are input for dialing when a sensor event occurs. When a sensor event is recognized, the software invokes an audible alarm attached to the system. After a delay that is specified by the homeowner during system configuration activities, the software dials a telephone number of a monitoring service, provides information about the location, reporting the nature of the event that has been detected. The telephone number will be redialed every 20 seconds until a telephone connection is obtained. So this is how the stories are written. So for example, you are trying to make the system, and you met lots of different stakeholders, a lot of different housekeepers, that what kind of a system that they desire, and this is what you ended up with, that they want a system which they can configure themselves, which they can access through PC or a control panel, and they want to also have telephone numbers programmed into it to respond to certain events. For example, there is fire in the house, you want to call fire brigade, or if somebody has broken in, you want to maybe call the police. So this is what the user stories might look like. And when we are doing this grammatical parse, what we want is we want to highlight and we want to underline all the nouns that we can. So if we look at all these 4 stories, then the nouns are these. So for example, the safe home security function. The safe home security function, that is a noun clause. Then we have enables the homeowner, which is a noun, to configure the security system, again a noun. Monitors all the sensors connected to the security system and interacts with the homeowner through internet, PC, and a control panel. During installation, the safe home PC, which we have already identified as a noun, is used to program and configure the system. Each sensor is assigned a number, type, a master password. Again, these are noun clauses. And then we have this telephone number. We have this delay time, alarm, monitoring, telephone, connection. So what we do is we do a grammatical parse, and we identify all the nouns and noun clauses. But some of them are very clear to us. For example, when we look at it, we can clearly say, okay, a number cannot be a domain class. Okay, but this may not be as simple as these statements may look like, and you might have lots of text that you have gathered during the elicitation, and you might have created, I don't know, maybe 20 use case diagrams, and for those 20 diagrams you have written use case text which is on 40 pages. So you might have a lot of text to go through, and you might end up identifying lots of nouns and noun clauses, and clearly not all of them are classes, as we have seen, but we need a proper method to say, okay, this is not a class because it doesn't satisfy these few conditions. So let's look at, how do we classify them, and how do we establish those, or what are those criterions on the basis of which we decide whether identified noun or a noun clause would be a domain class or not. So the first thing is that how do we classify these classes? So all the nouns and noun clauses we have identified, we call them potential classes, okay, because they have the potential to be a class, because that's why we have identified them. And all those potential classes can be classified into these 7 categories, into any one of these 7 categories. So you have either it is an external entity. So external entity could be another system which is outside the boundary again. A device or a person. So for example, you can say that this external entity is the actor as we defined in the use case diagrams. Then it can be a thing. For example, it can be any reports, it can be the screen display. So anything which is related to so for example, in this case of safe home, the display that you have on this control panel, that is a thing, okay. Similarly, occurrence and event. So again, in the case of safe home, occurrence and events are that, for example, you have the fire in the house, or somebody breaks in, or and again you dial a number, and these kind of things. These are all occurrences or events. And similarly, then roles. For example, the example of the roles are a manager, engineer, salesperson, or maybe the user of the system. Then you have different organizational units, for example, division, group, team, and in this case, for example, then you have different classifications of place. So for example, this information might be important, that whether the fire started on the ground floor or in the kitchen or in the first floor, so where the fire started. So maybe the place information is important. So in the case of safe home, you can have maybe different floors of the house, different rooms, you can say that these are the places. And then you have structure. So for example, in this particular case, the sensors, they can be classified as structure. So all the nouns that you have identified, you want to classify them as one of these types. So even if you look at all the broader problems, then these 7 classifications, they actually fit, all the classes or all the potential classes would fit in any one of these. So you have these external entities, which we said is similar to the actor definition that we used for use cases. Then you have things, and the example can be the display and the reports. Then you have occurrences or events, which is any moment or completion of something. Then you have roles, which is, for example, the people who are actually using the system, and in this particular case it may be only the home user or maybe the police. So these 2 are the roles. And then you have the organizational units, which examples are group, team, and divisions. Then you have place, and as I said, in the case of safe home, it can be different rooms or the location of different sensors, which is very important because we want to know where the fire started from. And then you have the structure, and in the structure, in this particular example, we have sensors. It can be a vehicle, it can be computer, or anything. So all the classes, we need to classify them, and we classify them using these 7 categories. And another thing that we said, that we need a criteria to say, okay, that this is not a class and this is a class. So we use these 6. So as we said, that all the potential classes, they should satisfy all the conditions. So these are our conditions of saying that whether a noun would become a class or not. So these are the 6 criterions, and each class should satisfy all of them. But normally there is an exception to one of the one type of classes, and that is external entity. So what we do is that if a potential class is an external entity and it does not satisfy any one of these 5, but that is essential to our system. If it's essential to our system and it's an external entity, then we say, okay, we will make it a domain class. So this is the only exception. Any other kind of a class, for example, it's a thing, it's a role, it's a place, it's an organizational unit. So any other kind of a class, if it does not satisfy any one of these 6 criterion, then we do not make it a domain class. So the only exception is the external entity, and if the external entity is an essential requirement as well. So what do we mean by each one of these? So for example, when we say retained information, so we will only make a noun a class if we need to store something about it. For example, in case of the sensors, we need to store something about the sensor. We need to store, okay, what is the sensor type, what are the sensor values right now, what are those exception values on which we are going to trigger some events, and where the sensor is installed. But so for example, if our potential noun that we identified was sensor, then we might we are retaining some information about it. Similarly, the class or the different attributes that we have identified of the class, it needs some services. So we should not have a class where we are storing something about it in form of its attributes, but it should need some services. There should be some operations which can be applied on the instances of that class. For example, we have one fire sensor or smoke sensor installed in the kitchen, and we have certain attributes of the smoke sensor. For example, we have said, okay, the type is a smoke sensor, and this is the permissible limit of the smoke that is allowed. If it goes beyond that, then it needs an operation. And the operation is that it needs to trigger an alarm, fire alarm, and it needs to, maybe the control panel, from the control panel, a telephone should be, a call should be made to the fire station or to the fire department, indicating that there is fire in this house. So again, so a noun should not, a noun or a potential class should not only have some attributes where we need to store some information about a particular instance of that class, but it should also require some services. Another thing is that okay, we are trying to retain some information, but is it just one attribute or is it multiple attributes? So we would want to make a noun or potential class a class in a, we want to say, okay, this potential class will become a domain class in my solution if it has multiple attributes. So if we are making classes just because we are storing just one information about a certain object, then that should not be a class. That's what it says, that a class should have multiple attributes, or any instance of a particular class should have multiple attributes for which we want to store some information. And then it should have some common attributes. By common attributes, we mean that if we make multiple instances of a class, then across all those instances, it should have some commonalities. So if you look at this example of, for example, from the learning manual, or if you again look at the example of the sensor, then it has some common attributes. For example, each sensor has some sensor type. And the location of the sensor, so it has some common attributes. Similarly, if you look at the student example, and the student is of the type role, a student would be classified as a role if we use the classification scheme that we saw in our previous slide. And it has some multiple, we need to retain some information about students. Each student needs some services. For example, student need to register courses, student need to view his attendance, student need to view his marks, and there are lots of things that student might do with the system. Similarly, a student instance would have multiple attributes. So for example, you want to store the student name, you want to store his GPA, you want to store his father's name, his ID card number, and which courses, which semester he's in. You want to store lots of information. And similarly, lots of these students would have some common attributes. For example, for each student you have student name, student ID, it has lots of common attributes, and moreover, each student required some common operations as well. So for example, the view attendance, view marks, and all those operations, they would be required by all the instances of this class student. And similarly, all the sensors would have some common operations. For example, we need to poll each sensor after a certain while to look at the values. Okay, or an interrupt would be, whenever an interrupt is generated by the sensor, then there should be a function which actually tells our control panel that what to do. So there are some common operations which are required by all the instances of the sensor. And then we have these essential requirements. And as I said, that essential requirement, for example, in this particular scenario, if we have an alarm that is installed as an external device, now alarm is an essential requirement. It's an external entity which is outside the boundary of the safe home system that we are designing, but it is essential because without the alarm this whole system is useless. And so this is essential. It is an external entity, although it does not satisfy the above criterion, but we will say, okay, we'll make it a domain class. And that is true also for the camera as well. So these are the 6 criterion, and as we said that when we identify potential classes, all those potential classes should satisfy all of these criterion. The only exception is the external entity, and if it's essential as well to the system. So if you remember from the grammatical parts, we identified lots of potential classes. For example, we said that the homeowner is a potential class. Now its classification is a role. Okay. And this is an external entity, and why it's an external entity? Because we said that if it's something which is outside the boundary of the system, and so this is an external entity. And then we say, okay, why are we rejecting it? Okay, this is important because we thought that user, we need to store some information about the user, but when we looked at it, when we looked at the systems, and this is where the analysis part kicks in, that, you know, by just looking at that scenario and the story, we said, okay, homeowner would be a class. But when we looked at those criterion and we saw, okay, we need to store some information about the homeowner, but what information do we need to store? If you look, if you have ever seen those products, then what normally happens is that the only information that you need to store is a PIN number. So for example, there are 5 people who are living in that house, and each one of them, they actually know the PIN number. For example, whenever they are getting out of the house, and so they will just enable the alarm. When they're coming in, they will disable the alarm. When they're sleeping, they will enable the alarm again. So it is not important that whether out of those 5 people who is actually, you know, using the control panel. So that is why we do not want to retain any information about the homeowner. For example, we don't want to retain the information about the, I don't know, the age of the person, name of the person, or ID of the person. And similarly, it does not need any services as such. So it fails those 1 and 2 criterion. So we say, okay, we will reject it as a class. And then, as we saw when we were discussing those different criterion, that sensor is an external entity, because it's not part of the system, because we are going to buy sensors, we are going to deploy these sensors, our system is actually going to get some information about the sensor. So if we make this use case diagram, then the sensors would be an actor. They will be outside. So this is an external entity. So we know this is an external entity, but we need to accept it, because we said that it satisfies all those criterion. As we looked when we were looking at the different criterion, we discussed that. Similarly, control panel, that is an external entity, and we need that, so we are going to accept that. Similarly, installation is an occurrence, because the system would be installed just once, and we say, okay, we are going to reject it, we are not going to need, so it fails almost all of those. Then we have this security system. Now it's a thing, and again this is an accept, because we are we need to retain some information about it, it needs some services, it has some common attributes. Then we have these number and types. These are not objects, these are just attributes. And they fail this the third criterion. And what was the third criterion? The third criterion was multiple attributes. Now this is just one attribute, a number and type. So it clearly shows, okay, this is just one attribute. So we do not need to store something about this attribute. So it just fails the criteria 3. So okay, we say it's a reject. Similarly, master passwords, it's a reject. Telephone number, it's a reject. Sensor event, now that is an occurrence. And for different type of sensor events, we need to record some information. Different type of events need some services, they need some operations, they would have some common attributes, they would have some common operations. So it's an accept. So we say, okay, we are going to accept it. Then the next one that we have is the audible alarm. Okay, now that is an external entity, and I told you that this is an essential requirement as well. So what happens here is that we are going to accept it even though it fails 1. Whereas if it would have been any other potential class and it was not an external entity, we would have rejected it. But we are accepting it because the system is going to be useless without an audible alarm. And then we have this monitoring service, which is again a reject. So this is how, as an analyst, we gain more understanding about the information domain of the product, that we have the user stories, we had all that use case text. We say, okay, we are going to identify some potential classes, and we have a classification criteria of these classes. We say, okay, these potential classes are classified as external entity, as a thing, as an occurrence, or as a role. And then we have certain criterion, and we look, for each potential class, we need to, all the criterions must be satisfied, and then we accept and reject some classes. So out of I don't know, these 10 and 11 potential classes, we have accepted only 5. So you can see that how, as an analyst, you are gaining more knowledge about the system, more knowledge about the information domain. So the next thing is, as we all know, that in a class there are the first thing is a class. Then the next thing in a class each class has some attributes, which we have said that a class should we need to store some information about the class, and it should not only have one attribute, but you should have multiple attributes. So how an analyst, once he has identified those classes, how would you go about identifying what information do you need to store for a particular class or for a particular instance of that class? So let's have a quick look at that. That attributes of a class are those nouns from the grammatical parts that reasonably belong to a class. So for example, we saw lots of different nouns which we identified as potential classes, and we accepted some of those and we rejected most of those. And all those rejected nouns, they become the attributes of different classes. So we now need to match those rejected nouns to the identified or accepted classes or the domain classes. And which one you think that it belongs to, we say, okay, this is an attribute of this class. So for example, sensor type would be an attribute of the class sensor because it clearly belongs to that particular domain class. So attributes, they hold the values that describe the current properties or state of a class. An attribute may also appear initially as a potential class that is later rejected because of the class selection criteria, which we have already seen. In identifying attributes, the following question should be answered. What data items will fully define a specific class in the context of a problem at hand? As I gave the example of the sensor event. Usually an item is not an attribute if more than one of them is to be associated with a class. So, so for example, you know, if we have that sensor class, then each sensor would have just one type. So we say, okay, this is an attribute of this particular class. Okay, and so we've seen, okay, that we have identified classes, we have identified attributes, but another thing that each class has, and we saw in the selection criteria, that all those domain classes that we have identified, they should need some services, okay, and each instance of that class, it should have some common operations across the board for the class as a whole. So what is an operation? The operations define behavior of an object. So again, you can see that how we are building on. When we did that scenario-based modeling, we looked at the functionality of the system from the user's point of view. Now we identified the domain classes, so we are gaining knowledge about information domain when we identified these domain classes. But now we are talking about the attributes and the operations of a class, so we are gaining more knowledge about the behavior of the system or behavior of an object in this particular case. So there are 4 categories of the operations. Operations that manipulate data in some way to change the state of an object. For example, addition, deletion and modification are very simple example of such operations. They manipulate the data and they change the state of the object. Operations that perform a computation. Operations that inquire about the state of an object. For example, in case of the sensor, if we are doing regular polling after every 10 seconds or after every 5 seconds, so that is an operation which is just inquiring about the state of the object. And operations that monitor an object for the occurrence of a controlling event. So, and there might be some operations which, you know, when poll, it generates some output, and which you need an operation which is going to control an event. For example, sound an alarm, or, you know, call a certain telephone number. So there would be some operations as well which are monitoring an object. So there are 4 kind of operations. One that change the state of an object and which manipulate the data. There are others which perform a computation. Then there are others which inquire about the state of the object. And there are others which monitor an object for a controlling event. So what does an operation know about a class? An operation has knowledge about the state of a class and the nature of its associations. So operation not only knows the state of the class, it also knows what association does this class has with other classes, because through these operations you can talk to other classes as well. And the action performed by an operation is based on the current values of the attributes of a class. So this is very important to understand, that when we say that a class needs some services, so what it actually means is that each class would have some attributes, because we are retaining some information about this class, and then this operation would be, the service would be performed on those stored values or on the attributes of that particular instance of that class. So again, we go back to the basics and we say, okay, the grammatical parts that we did to identify those information domain classes and to identify those attributes, we'll do that grammatical parts again. But now our purpose is to identify all the verbs, okay? Because verbs are the action words, and action are the things which we classify as operations on those different classes or on those different attributes of those classes. So again, let's look at this example, and we've already went through it. Now, if we want to identify different operations in it, for example, the same home security function enables the homeowner. Now, that enables is an operation to configure the security system. So we know configuration is another system. When it is not, monitors all the sensors. So monitoring is another verb. So what we do is we try to go through it. We do a grammatical parse, but now the purpose is different. We are trying to identify different operations. We are trying to understand the behavior of different classes. So we identify all the verbs, and so we have seen enables, configure, install, monitors, and we do something similar to what we did with when we say, okay, the remaining or the rejected noun or noun clauses, we are going to classify each one of them as a attribute of different classes. So we are going to do something similar here. We have identified all these verbs. Now what we do is we try to associate a verb to a class to which it seems more close to. So for example, monitors. So monitors a sensor. We know, okay, this belongs to the sensor class because we have sensors, and we have different types of sensors, and we need to monitor them. So monitor function would belong to the sensor class. So let's look at this one sample class diagram or information domain class, which we have identified as a result of this whole class-based modeling. That we've said, okay, this class is the system class, and for the system class, what attributes we have identified. So for the system class, what attributes we have identified. So we've said each system would have an ID. It would have some verification phone number. It would record the system status. It would have delay time, telephone number, master password, temporary password, number tries. So the system is storing all these information. And if you remember that when we did the initial grammatical parts and we identified those noun classes, then this master password, telephone number, and these all, and this we identified them as noun classes, but we rejected them, and now we put them in the system class. And then we need to identify, you know, the operations of these class, and we said we do another grammatical parse. We identify the verbs, and we figured out that, you know, as a homeowner, as a user, you need to program it, and the system should display some information to the user. You should be able to reset the system. You should be able to inquire. You should be able to modify. For example, you know, you want to sound the alarm for a certain number of time, and you have different preferences. For example, you want to sound the alarm until somebody comes in and reset the system. So there are different priorities you can have, and you have identified that this is how. And if we look at all the operations, now this program operation, it would be performed on, you know, these operations that you are maybe programming your master password, you are changing your temporary password, you are changing your number tries, and similarly this display is going to display the system status, or display is going to display the system ID and all these different attributes. So as we said, that these operations are applied on the attributes of a class. So whatever operations we have identified, they are going to be applied on the different attributes of these classes. So that is what we are going to discuss in today's class. We are almost ending reaching the end of the lecture. So we have discussed, mainly we have discussed class-based modeling. And so let's quickly recap what we have done and try to, again, look at this lecture in a way that you are not trying to know about class diagrams because you already know that. You are trying to understand the importance of identifying these class diagrams in this fashion as a requirement analyst. So let's quickly recap what we have done in today's lecture. So we started our lecture with a quick example of the Swimline diagram, and we continued with our example that we were finishing in our previous lecture. But the main topic that we covered in today's lecture is class-based modeling. And so what we did today was we said that, you know, so what we did was we basically looked at class-based modeling. And the important thing to note here is that, as I've been emphasizing in this lecture again and again, that we do not want to know how a class diagram is made because we already know that. But remember the three things that we said in the elaboration process. That elaboration process helps us in knowing about information domain. It tells us about different functions, and it also gives us information about the behavior of the system. So that is what analysis and elaboration process is all about. So we saw that in scenario-based modeling, we were able to identify from a user points of view what are the functions our system should have and how our system should behave. But now from the information domain point of view, we want to know that, you know, if we are using this object-oriented approach to analyze the system, what are the main classes, what would be the domain classes in my system? And we said that the only information that we have at this stage is the requirements that we have elicited from the clients, and they are not even structured. We have certain scenarios, we have certain user stories, we have some prescribed interviews, you know, whatever technique we have utilized when eliciting requirements. So how do we identify classes? we said that we do a very simple grammatical parse. So we do a grammatical parse, and in that parse we identify all the nouns and noun clauses. And these nouns and noun clauses, all of them, they become these potential classes. And out of those, because we may end up with, I don't know, 50, or if it's a big system, we may end up with hundreds of these potential classes, but they cannot, all of them cannot become the domain classes. Why they cannot? So the first thing that we do with all these potential classes is that we need to classify them, because classification gives us more information about whatever potential classes we have identified. And we said that there are different classifications. For example, a class can be an external entity, it can be a thing, it can be a role, it can be a manufacturing place, or it can be an essential requirement. So a class can be classified into those 7 different classes. But the next thing, which is very important, because our goal is to identify our domain classes. So we need a criteria, we need a proper mechanism to say, okay, this will be selected as a class and this will not. Because as I said, that some things are very simple. For example, an attribute such as a telephone number or an ID, we know that this cannot be a class, but we need a proper mechanism to say, okay, it is not a class because it does not satisfy this certain criterion. So we said that there are 6 criterions on the basis of which we will check each one of those potential classes, and if a potential class satisfies all 6 of them, we will make it a domain class, otherwise we are going to reject it. So our class selection criteria included that we need we check a potential class for retained information, whether we want to store some information about this particular instance of this class, whether this class or the attributes of this class would be needing some services, and it should have multiple attributes. So we cannot make a potential class a class if we are just storing some, just one attribute, or we are just storing just one information about it. So it should have multiple attributes. So each instance of class should have multiple things for which we want to retain some information. It should have multiple common attributes across different instances of class. It should have some common operations. So each class should satisfy all these 6 criterion, and the final one was essential requirements. And we said that there is an exception to this class selection process, that if a class is an external entity and it satisfies that criteria of essential requirement, then that is an exception. As we saw the example of alarm and the camera, that they do not satisfy the multiple attributes or the common multiple attributes, for example, criterion. But and we said that if a class doesn't satisfy any criteria, we reject it. But we accepted it because it was an external entity, and our system was useless without an alarm, and it was an essential requirement as well. So we had this class selection criteria. On the basis of this criteria, we identify domain classes. But a class also has some attributes. So how do we go about identifying attributes? So as we discussed, that all the nouns which we rejected as those domain classes, we look at all those nouns and we try to see, okay, which noun seems to be more close to a certain domain class, and we start grouping them. And on the basis of that, we say, okay, these attributes, they belong to, for example, the sensor class. These attributes, they belong to the system class. For example, the master password, the system ID, or the number of retries, or system information. These all belong to the system class. So we put all these attributes in that class. And the next thing that a class has is operations. And these operations, they actually tell us about the behavior of that. So remember, as a requirement analyst, this is something which we are interested in. We are interested in knowing the behavior of the system. And if we are using this object-oriented approach, then we want to know the behavior of the classes. And by identifying these operations, we can identify the behavior of each class. So how do we identify these operations? We again do this grammatical parts, but now the purpose is to identify verbs. And once we have identified verbs, we try to associate them to different domain classes, and by doing so, we complete one class. So we'll do it for each identified domain class. We'll try to put some attributes in a class. We'll try to figure out what are the operations of this class. So again, remember that as an analyst, I have not only understood about the information domain by identifying domain classes, I've also looked at different operations, and by looking at those different functions or different operations of domain classes, I have understood also the behavior of different domain classes. So that is it from today's lecture. And the next lecture, we are going to continue our discussion on this class-based modeling, and we will also be covering the behavioral modeling. Take care, and Allah Hafiz.